Hello, we are discussing about GATE 2002 ECE paper, and this question is related to analog circuits. Look at the diagram given. The diagram is going to be this one. It is going to be consisting of, this is gain versus frequency. Frequency response of an RC coupled amplifier is going to be given with 20 Hz as lower cutoff frequency, 1 kHz as upper cutoff frequency. Okay, it is given 3 identical RC coupled transistor amplifiers are cascaded. 3 identical RC coupled amplifiers are cascaded if each of the amplifier has a frequency response as shown in the figure. This is what the frequency response. The overall frequency response is. There are 4 options are given: A, B, C, D. This is A, B, C, D. So out of these 4 options, what will be the right choice if 3 such type of amplifiers are going to be cascaded? So you must remember one point: whenever we are going for the cascading of amplifiers, always results in increasing in gain. That is nothing but gain increases, but bandwidth is going to be reduces. Overall bandwidth is going to be reduced. Overall bandwidth is reduces, and overall gain is going to be increases. So whenever amplifiers are cascaded, gain is increases and bandwidth is going to be reduces. Okay, let us assume if you want to calculate bandwidth of a single stage, at that time you can calculate it as FH minus FL. That is, the difference between upper and lower cutoff frequencies is nothing but bandwidth. Okay, so here it is, the effective bandwidth, overall bandwidth is reducing, is nothing but bandwidth has to reduce. How can we say that one bandwidth is going to be reducing? Bandwidth is going to be reducing. That is nothing but this difference, FH minus FL. This difference has to reduce. This difference has to reduce implies nothing but, okay, we can think in this way. As FH is going to be, if upper cutoff frequency is going to be reducing and lower cutoff frequency is going to be increasing, at that time the difference between these two things get reduced compared to the previous case. So whenever amplifiers are cascaded, at that time gain increases, bandwidth reduces. Bandwidth reduces because the lower cutoff frequency is going to be increases and upper cutoff frequency is going to be reduces, so that the difference gets reduced. That implies nothing but bandwidth is reducing. So with the help of this statement, we can easily identify the answer. Later we will see with exact equations whether you are getting the answer or not. So first of all, FH has to reduce. That is nothing but overall FH has to be lesser than 1 kHz. Remember that one, 1 kHz. And FL has to be greater than 20 Hz. Okay, so these are the conditions for the answer. So FH should be less than 1 kHz. So if you observe these things, at that time 1 kHz lesser than 1 kHz is nothing but either it may be D or it may be A, because A and D, these two are going to be having upper cutoff frequencies as 0.5 kHz. So which satisfies the upper cutoff frequency should be less than 1 kHz. Now you should check for the lower cutoff frequency. Lower cutoff frequency should be greater than 20 kHz. But in case of D, if you observe, it is not satisfying. Lower cutoff frequency is 10 Hz. It is lesser than the required condition. So the condition is not satisfied for the D in case of lower cutoff frequency. So look at the lower cutoff frequency in case of A. That is 40 Hz. 40 Hz is greater than 20 Hz. And FH is less than 1 kHz. FL is greater than 20 kHz. So the right answer for this one is A. Overall frequency response of the given question is A. And now we will go with exact equations. How do we calculate the lower and upper cutoff frequencies if identical amplifiers are cascaded? Okay, so let FL is going to be in lower cutoff frequency of individual amplifier, and FH is going to be upper cutoff frequency of individual amplifier, and we are going with all amplifiers are of identical type. And overall lower cutoff frequency is with asterisk. FL with asterisk is nothing but overall lower cutoff frequency, overall FL, and FH with asterisk is nothing but overall FH. Overall FH is nothing but with cascading. So this can be calculated. FL with asterisk is nothing but, okay, FL divided by square root of 2 power 1 by n minus 1, and FH is equal to FH with asterisk, FH with cascading, FH into 2 power 1 by n, 2 power 1 by n minus 1, where n is equal to, number of amplifiers in cascading, number of amplifiers cascaded. How many number of amplifiers cascaded? In case of this question, n is equal to 3. So what you are going with is nothing but simply substitute n with 3. So FL divided by 2 power 1 by 3 minus 1, and FH into square root of 2 power 1 by 3 minus 1, and FL is 20 Hz, FH is 1 kHz. If you substitute the values at that time, FL with cascading is going to be equal to 39.22 Hz, which is approximately equal to 40 Hz, and FH with asterisk is nothing but 0.5 kHz. So this is what we are going to get. So with respect to formulas, these are the formulas related to the cascading of amplifiers. That is, lower cutoff frequencies increases, upper cutoff frequencies decreases. Remember that when you are writing it in the denominator, root of 2 power 1 by n minus 1, always this will be less than 1 only, so that it will be in the denominator for the lower cutoff frequency. So lower cutoff frequencies increases, whereas in case of upper cutoff frequency, this term square root of 2 power 1 by n minus 1, which will appear in the numerator, since the value of this term is going to be less than 1, overall upper cutoff frequency is going to be gets reduced. So the right answer for this question is A. With overall lower cutoff frequency 40 Hz, overall upper cutoff frequency is 0.5 kHz. The required frequency response option is A. Thank you.